Welcome everybody, thanks for coming. My name is Brian Mariani. We're going to talk about astronomy tonight, my favorite presentation, and how the heavens declare the glory of God. So I love it, it's awesome. We're going to see here, this is one of the hard sciences that we can look at and observe and test things. Not as much testing actually, more observing and more trying to figure out what's going on out there in the universe. But we also have geology, biology, and anthropology as well. And with those, there's sciences and there's evidence like rocks or living things and with cells in them, or language and things like that. But in all of that evidence, we have to interpret the evidence. And so oftentimes you have these different evidences and you can interpret them according to evolution and naturalism, that there's a natural explanation for everything, or you can interpret everything according to God's Word, according to the Bible, which is a totally different topic, but it's very well documented, very well presented. It's as history and very well recorded record of history. So I think that's important to realize that hey, this is a good record of history. So, but it's kind of this deal. When we're looking at evidence, we might both be looking at the same evidence. We're looking here in this case, in this slide, these two scientists looking at the cell. And one of them says, "Isn't evolution wonderful?" The other one's saying, "What an awesome, powerful creator." And I think it's more on that line, that, wow, what an awesome, powerful creator. So obviously, we've got evidence, scientific evidence, but it ultimately comes down to faith. And what are we going to have faith in? Okay? And we'll look at that more. We'll see more about that later. But I love this quote. It's from National Geographic, which is really devoted to evolution, to millions of years. And they say here, this is an archaeologist working at the Cahokia Mounds for 40 years. He says you put 3 archaeologists in a room together and you get 5 opinions. 3 archaeologists, you get 5. Wait a second, the math there doesn't make sense, does it? And that's kind of the thing. That's kind of the problem, is that, well, with the same evidence, we should all come up with the same conclusion, right? And hopefully that would be the case. Normally, maybe it would be the case, but still there's subjectivity, there's bias, and there's still we can't prove it for sure or 100%. Obviously, in the court of law, when you're trying to prove something, you can't prove it 100% just beyond a reasonable doubt, right? So that's what's going on here in a lot of cases. And so I've come up with a list of what I think is up to 80 different challenges, and you could add more to the list too. Challenges to the theory of evolution, challenges to the naturalistic perspective that there is no God, everything's come about naturally throughout time, and I think these are big problems indeed. And you maybe can't see that on the screen very well, but that's another, we can talk more about that in other resources and in other times. But we're going to look tonight specifically about this comparing the two timelines. We've got the timeline, the biblical timeline as we have it recorded in the Bible, where in the beginning God created, and then there was the fall of man right there, the fall of man, and how Adam and Eve sinned, just like we all sin today, right? Then you have the flood of Noah's day. Shortly after that would have been the Tower of Babel, and then also the Ice Age was during those hundreds of years after the flood, and then obviously 2,000 years ago the cross of Christ. Jesus died on the cross, and then we have today, and then obviously into the future, right? So now what was it? In the beginning, what was in the beginning? God, right? The first 4 words of the Bible. In the beginning, God. So that gives us our starting point for everything, right? If all of the universe had a beginning, which it appears like it all had a beginning, and that's what we'd expect from the law of cause and effect, what created all of that? And that we believe is God, and I think there's good evidence for that. Not just blind faith. We believe it, not just blind faith though, but we, I think, have evidence to back up our faith as well. We have the laws of logic, the laws of science, thermodynamics, gravity, things like that, physics, and I think all those laws really are based on who God is, right? They're based on who God is. He's a God of order and not disorder. With the biblical timeline, if we look at it very plainly, and obviously this is debated, but it appears like it's talking about 6,000 years, and we kind of know that based on this guy lived so long and he died, lived so long and he died, lived so long and he died, and we count up all the years. It's a record of history, right? And I think it's a well-written record of history. So around 6,000 years is where we'd say the biblical timeline is here in this case. The naturalistic timeline, very different, especially the timing of that. 13.7 billion years of history, very different than 6,000 years, isn't it? And what was in the beginning for their timeline? What was in the beginning for naturalism, where there is no God or there is no supernatural? What was in the beginning? Nothing, really, unless you want to try to say that the universe is eternal. And there are some challenges there too, and really that doesn't hold up very well either. But nothing. And then that blew up into everything, right? Or expanded into everything. That's called the Big Bang, right? And that's where you get planets and stars and comets and galaxies and all these things. And so we've got the Big Bang right there at the beginning. Again, what was before the Big Bang? Nothing, really. And a lot of people will say the multiverse theory, but ultimately that's kind of, we can't prove that. That's outside of our universe. That we maybe can find some indirect clues to that, some indirect evidence, maybe for a multiverse is what a lot of people are hoping for. But ultimately, even think about that. If it's outside of our universe, outside of the natural universe we have, the multiverse is a supernatural belief or perspective of creating it. And I think obviously if we're looking at two supernatural options, I think our supernatural option is going to be the best, right? It explains the best, I would say. And we'll keep looking at that. So nothing. And here's Discover Magazine. Where did everything come from? And I'll blow up the quote in the bottom there. The universe burst into something from absolutely nothing. Zero. Nada. As it got bigger, it became filled with even more stuff that came from absolutely nowhere. How is that possible? Ask Alan Guth. His theory of inflation helps explain everything. So I'm glad at least Alan Guth is out there to help us figure it out. But it kind of sounds funny, doesn't it? It came from, something came from nothing. And nothing then would be the first cause, the law of cause and effect, where everything that has started, that has a beginning, must have a cause, and that is what we experience logically in common everyday experience. But nothing doesn't really explain it very well, right? So the Big Bang contradicts the known principles of science, known laws like the law of cause and effect, laws of thermodynamics, gas laws, laws of gravitation, things like that. We're not going to get totally into a lot of the details of these things tonight, but I think it's interesting. Hawking's nothing is really gravity. He really puts a lot of weight on gravity. That's silly. But for him, gravity becomes God, right? He's trying to explain it without God, and he's looking to only natural perspectives, and I don't think they fit as well as a creator God would. In fact, I think the law of gravity suggests a lawgiver. It is consistent with creation, biblical creation, with the Bible. In fact, we see problems with the Big Bang. The flatness problem, missing antimatter, the horizon problem, where did it come from, and how did it expand? Those are big problems, right? And I'm not trying to say, well, we can't figure these things out, so let's just stop our research. Absolutely not. I think we want to keep studying these things, but maybe our conclusions are wrong if we're concluding the Big Bang Theory, right? In fact, a lot of times when we look at this Big Bang model, this Big Bang Theory, you have to add to it. The multiverse theory, like we already talked about. The inflation theory, how did it expand so fast? And how did it clump together so you could get stars forming or galaxies forming? You need things to inflate faster in different places, but it's just adding more complicatedness, if that's a word, complicatedness, it's adding more to the theory, which doesn't really help, doesn't make sense, right? And then dark matter and dark energy. We're going to talk about that a little bit later, but very little is known about that. That's why it's dark, is we can't observe it and figure it out yet, really. So the naturalistic timeline here, we've got, and then you've got, think of the laws. If we're trying to explain everything without a designer creator, where did the laws of logic come from? Where did the laws of physics come from, and thermodynamics, and the laws of gravity? Why does it all work consistently, and we can expect that it always will? There's some explanations that a naturalist will try to explain those laws, but it really kind of breaks down to where they can't explain the laws very well anyways. And I can give you an article that talks about those laws. Can't be explained really without a designer creator, at least not very well. And then nothing doesn't really become everything. You know, that'd be really cool if I could make something from nothing, right? Gold bricks. Not even out of thin air, not even out of air, because air is something, but gold bricks out of nothing. I could be pretty rich, but that's never going to happen, right? We know from the law of conservation of mass and energy that you cannot create or destroy mass, right? Or mass and energy. You can change them around a little, but you can't destroy them. And the Big Bang, as we talked about, has those problems. You have to add to the model, and it's not as strong, does not explain the evidence we see very well. We're going to keep seeing that as we keep going. This is one of my favorites, star and planet formation. How do stars form? How do planets form? You have dense gas clouds, and these dense gas clouds keep collapsing. You have to, or are pushed, squashed together. And that might start spinning and will light up into a star. And then you get planets forming around that star as well. And so when we look in outer space, we see maybe stars are born out here in these big gas clouds where gas is compressed into a star. But what we know about gas is that this is what gas does, right? Gas goes like this. It's going all over the place. This is a solid. It's moving a little bit. The liquid's moving a little bit more. The molecules are moving around a little bit more in there. A gas, everything's just going, and it's got energy to go. And so, I mean, you know that if I break a bottle of perfume right here, those gas molecules, they're going to spread to fill the whole room, right? That's what gas does. It wants to, and then that's why you can pressurize containers, is because you can feel the pressure. If you squeeze a bottle, you can feel the air pressure in there because the air molecules are hitting the sides of the wall. That would be that air pressure, really. And so it actually takes these companies work to put the air inside the can, right? They don't press the top of the can for these spray paints or hairspray, right? You don't press the top of the can and air just automatically goes in normally, right? That wouldn't naturally happen. But with these different cans, that would be weird if it sucked all the air out of the room and formed a star inside the can, right? That would be kind of weird. That wouldn't happen. But we see it spreads out. It wants to get away from itself. That's what gas likes to do, is get away from itself. And so, how do you make a star? How do you get this gas cloud to clump up, to condense up enough, collapse, to form a star? And so there's ideas, there's options out there where they say maybe a supernova happens out there. It's an explosion out here in space, and it sends this shock wave in and smashes in this gas cloud, right? That's an option. Cooling from dust grains can make these gas clouds condense a little bit. Collisions of gas clouds, so imagine galaxies smashing together, could form that crunching. And radiation from a cluster of newborn stars could help energy to help heat it up and crunch it. Or radiation from black holes, so that they actually do radiate radiation from these black holes. And so, yeah, to energy, adding energy to the system to light up these stars. But it's interesting, really these are our only options for how to make a star. But notice, with each of these options, what's a supernova? A supernova. A supernova is an exploding star, or an exploded star. It's a star that explodes. And so my question is, how do you make the first star? How do you get the first gas cloud to clump? Because the supernova is not out there. So we can't make the first star, right? So that's not going to work. How about cooling from dust grains? I guess we could cross that first one off the list. Cooling from dust grains. Where do dust grains come from? From exploding stars or stars themselves. You can have heavier elements, dust, being created from stars. But you need stars to form dust. Collisions of gas clouds like in galaxies. Well, what are galaxies made up of? Stars. And radiation from a cluster of newborn stars. We already had stars. How do we make the first star? Radiation from black holes. Black holes are dead stars that have collapsed after they've burnt themselves up. They collapse. They're dead stars. So in each of these cases, we already had a star, so we don't know how you make the first star naturally without a designer creator. The origin of stars represents one of the most fundamental, unsolved problems of contemporary astrophysics. We are starting from a shaky foundation. We don't understand how a single star forms, yet we want to understand how 10 billion stars form, right? That's crazy. We don't know how stars form. I think that's fascinating. And it's, yes, keep researching, keep figuring it out. But at this point, from what we can see, we just can't explain it without a designer creator. So at this point, maybe that's more reasonable or logical. Planetary formation. You see at the top of this diagram here that you need just clumps of dirt to start, rock to start coming together, called accretion. And then those build into bigger and bigger planets that become the planets, really. So it kind of looks like this, where the planets, once the star is forming on the inside, the planets are cleaning up the outside of the solar system around the star. But have you ever thrown a rock at another rock? What happens to the two rocks? Right? They knock off of each other. Maybe if you throw a clump of mud up against a rock, maybe it'll stick. But in outer space, these are going to be frozen dirt clods, rocks, hitting each other. And what do we expect them to do when they hit each other? They break themselves down, right? So that's a big problem, too. In fact, here's a quote from Astronomy magazine that says, "But if it's not entirely clear how a bunch of pebbles manage to collide, stick together, and form kilometer-wide planetesimals," the beginnings of the planets. They can't figure it out. How did we get these things to start forming? Because gravity, you could say gravity maybe pulls them together, but gravity, just like the stars, right, the gas clouds, but gravity is a very, 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 very weak force. It is the weakest of the forces we know of today. Electricity and magnetism, that's a lot stronger of a force than gravity, or the weak and strong nuclear forces are a lot stronger than gravity. Gravity is really weak. In fact, all of us have a gravitational attraction to each other, as weird as that sounds. But it's so minuscule, so minute, that It really can't do it for us. In fact, here's an example of what we'd expect today. We see Saturn, beautiful planet, beautiful rings here, and those rings are made up of, you know, rock chunks, ice chunks out there floating around it. And if this is the case, if this is how planets form, would we expect a little moon to form around Saturn over time? Actually not, because what we're seeing and what we would expect is that these rings are going to be breaking themselves down finer and finer and finer into a smoother ring around the planet, and that's what we're seeing, that's what we would expect, not building up a moon. In fact, the planets also have big problems too, in fact, especially the Earth here, among other planets, but they have very strong magnetic fields, which if they're billions of years old, 4.5 billion of years old probably is what they estimate, 4.5 billion years old. If they're that old, how are their magnetic fields that strong? Because magnets, just like the magnets on your fridge, they weaken over time. They weaken. So how are these planets still strong, have strong enough magnetic fields? And the common idea is this dynamo effect, where you've got spinning stuff inside the Earth, and that spinning of charged particles makes a magnetic field, right? But over time, what do you expect the spinning stuff inside the Earth to do? Slow down. And so the magnetic field would weaken. Even with this dynamo effect, it's not enough for it to have survived 4.5 billion years of history. So that's a big problem for the Earth and for other planets too. They've gone past planets and they didn't expect them to have magnetic field, and oh, it does have a magnetic field, and it's fairly strong. That does not fit the evolutionary, naturalistic predictions. Interesting, right? And I think the magnetic field is there. God provided that, protects us with this magnetic field from all the harmful stuff, rays and things out in the universe. Solar system formation. So when we talk again about the sun and the planets forming, again we've got this big gas cloud. It crunches in somehow, mysteriously, to form the star on the inside, which takes up pretty much all the mass. Most all the mass goes to the middle, and it's going to start spinning too. And then the stuff around it will form, the planets around it will form as well. But if you think about it, have you ever watched the Olympics, right? You think about an ice skater, and she's spinning, and if she's spinning like this, she pulls her arms in, what happens? You can kind of see with me, although that was generated more so. But you pull mass in, you spin fast. And you can do this experiment with a spinning office chair. You know, spin yourself, pull your arms in, you'll spin faster, right? This is based on the law of the conservation of angular momentum. So if in the universe, in the solar system, our solar system, if pretty much all the mass, almost all the mass, 99.8% of the mass is the sun, it should be spinning pretty fast. And then of course we've got the planets are also revolving around the sun. But the sun doesn't have enough angular momentum. It's not spinning enough, it doesn't have enough for that energy. So that's a big problem. In fact, it turns out, here's the origin of the solar system, that the angular momentum problem is one of the most important hurdles to be negotiated by any plausible theory for the origin of the solar system. Another big problem. Are you starting to see this? You're starting to see we've got big problems. Not to say, oh, God did it, you know, stop all research. No, we want to keep figuring it out. We want to keep figuring it out. But it might seem like God is maybe the most reasonable explanation at this point. In fact, what's interesting, if we're talking about all that stuff coming together in one disc, in one, you think of it like a record player or a CD, in one disc, it's all moving. It should all be moving on this same disc, but the sun is actually tilted spinning a little bit tilted with respect to the way the planets are all orbiting, which is like, that's a big problem. That's huge, right? That's a big problem if they're all, because how do you get that whole sun to turn or shift, or how do you knock each one of those planets up a level in the way they're orbiting, and so that they're mostly in line there? That's crazy, right? In fact, we see with the planets and things that a lot of them are orbiting different or spinning differently. Venus spins different. In fact, the Earth even spins on an axis, right? And many of the planets have different axes. In fact, Uranus is actually rolling around the Earth instead of spinning around the sun. Uranus is rolling around the sun, which is not the way it's supposed to be, right? Not normal. But a lot of the moons are going backwards instead of all going the same way. Some are going backwards, which is weird. So we're seeing that's a big problem. And you might say, sure, an asteroid came and hit this moon, and now the moon spins the other way, a different way. But that means we've got a lot of big impacts, which we really don't have a lot of evidence for these big impacts with these planets, with these moons. We don't have the evidence for the impacts. So planets, and we're going through our timeline and what's appearing according to the evolutionary theory, not to scale here, but planets don't make sense without really a designer creator, okay? And galaxies. Galaxies, they're a big cluster. I mean, they're big. They're just made up of, trillions of stars, maybe. And so it takes time. If stars are starting to develop over time in the evolutionary history, the naturalistic history of billions of years, stars are starting to form, and then they're starting to collect together. It will take time for galaxies to form. And they estimate 3 to 6 billion years it would take galaxies to first start forming. But from their perspective, as we look further and further out in space, which means that's further and further back in time, because that light is coming from closer to the Big Bang. As we look back, they're finding galaxies already created, or already there, already developed, already mature, 2.5 billion years before after the Big Bang, which is before what they estimated. But it gets even worse. 2 billion years after the Big Bang only. 1.7 billion years after the Big Bang. 1 billion years after the Big Bang, and even 500 million years. They found some 500 million years after the Big Bang, they've already found a mature galaxy, which is that's like nothing for the billions of year models to be able to. That's like no time. That's like that they definitely do not have enough time to make mature galaxies in that amount of time. In fact, they have a hard time even trying to explain how galaxies form in the first place. But we see the presence of such fully evolved galaxies so early in the life of the cosmos is hard to explain, and has been a major puzzle for astronomers studying how galaxies form and evolve. This process is supposed to take billions of years. We have no idea why these galaxies grew so large so soon. The predictions continually are going backwards. In fact, that's what this researcher says here in Nature News, nature.com. The findings could overturn existing models for the formation and evolution of galaxies. That was the reason for the surprise, that it disagrees so radically with what the predictions told us we should be seeing. In fact, just 2015 or so, we got pictures of Pluto's surface, which was really cool, really great opportunity. And that even surprised us, or at least the naturalists anyways, that, the surface doesn't look as old as we thought it would. That's interesting. And different things as well that didn't match their predictions. Over and over again, we keep going out there, and it keeps going against really the naturalistic billions of years predictions. The problem of explaining the existence of galaxies, period, how did galaxies even form, is one of the thorniest in cosmology. By all rights, they just shouldn't be there. Yet there they sit. Listen to the words of this astronomer here. And he says, it's hard to convey the depth of frustration that this simple fact induces among scientists. See, why is he getting frustrated by this? Because if we can't explain it naturally without a designer creator, if we can't explain it that way, then maybe this way does explain it better. Maybe this is really the best and only alternative to it all happening without a God, naturally uncreated, right? Maybe it is created. The formation of galaxies and larger scale structures remains TMIUPIMA. The most important unsolved problem in modern astrophysics, right? We've seen a lot of this, haven't we? And it keeps going. So galaxies, can't explain it naturally without a designer creator. Comets, how about comets? Comets are basically dirty snowballs, right? That every time they go around the sun, what would happen to a snowball going towards the sun? It would melt, right? It would melt, gives it the nice tail coming off of it, and so basically if we've got dirty snowballs melting all the time, they're not going to last long. And based on their size and how big we think they can get, they wouldn't be able to last more than 100,000 years. 100,000 years, which again, I was talking about 500 million to the naturalists being such a short time to try to evolve galaxies. 100,000 is nothing if the sun's been around for 4.5 billion. Even give them 1 million or 100 million, right? We still would be out of comets. Comets would be melted away by now. They'd be gone. And in fact, I was taught in my Astronomy 100 or 101 class in college at a secular university, they said, oh yeah, we can explain that. Comets are thrown into the solar system from this Kuiper belt or this Oort cloud that are out there in outer space. And I thought, oh, okay, yeah, there's objects out there. Occasionally they hit and send one in toward the sun. Makes sense, totally. So I accepted it. Made sense. They explained it, that's it. It wasn't until years later that I was actually doing some research and found out they don't have enough evidence for the Kuiper belt or the Oort cloud actually being real and full of objects. They don't have much evidence. Maybe a few scraps of evidence, but not nearly enough evidence for the Kuiper belt or the Oort cloud. And you see, I believed, there's that concept again of we have faith in what we've been taught. We have faith in the scientific methodology, or not even methodology, but in the standards that we're taught as proven science, right? We have faith in that, but we want to look at the evidence. Does our faith match? Does the evidence match what our faith is in? Does that make sense? Is it backed by evidence? And so comets, doesn't seem like they could last billions of years. I think they were created, designed, and the universe might not be that old. How about the creation of the moon? This is cool, and I like this picture. Awesome picture. The creation of the moon. And this is the best, at this point, the best theory for the creation of the moon is that a Mars-sized object came and hit the Earth, and the two then reformed themselves into the one in the center, the one revolving around the outside with all the other stuff out there. That's called the giant impact theory. That's the best theory they have, but if you think about this big collision, is something like that, is that going to push the Earth and the moon into the sun or away from the sun? I mean, how do we have such a good, consistent revolution around the sun? You know, where maybe it's a little bit elliptical, I mean it's a little bit stretched out, but barely. It's mostly circular, which is good because otherwise we get too close and fry, or get too far away and freeze and go through that freezing thawing, right? That would be a problem for us, especially as we're evolving over billions of years on Earth, if that's the case, which I don't think it is. But even with this, you imagine, well, all that stuff, wouldn't it all fall back to one specific point? How do you get that other one moving around the Earth in such a consistent way? So there's problems with that theory. There's problems with the capture theory is one of their other ideas. See, they have 4 or 5-ish different models or ideas. I shouldn't maybe call them theories, but a lot of times they're labeled with theories. And this is one of them, the capture theory, that our Earth, the moon came too close and was captured into Earth's orbit. You have to have some other objects making that pretty precise capture, but there's some problems with that based on the composition of the Earth and moon, and where the moon is orbiting is very precise around the Earth's, I believe, elliptic. We have the condensation theory, which is similar to the accretion theory, that basically the two have formed at the same time or shortly in a matter of time around each other, formed independently. But again, why would this one cloud form the one in the inside, the one on the outside? And we're going to see in just a minute how the movement of the moon is even a problem for these billions of years. This is one of, I think, the funniest ones. The fission theory, in that this is early on in the supposed evolution of planet Earth, that it's a molten planet, it's a lava planet, and it's spinning so fast that bloop, the moon bloops off of the Earth, right? Which is, it's kind of silly, isn't it? There's a lot of problems with physics of trying to get that to work just right, and that it would actually still be out there in space and not come and smash back in. I think probably this is one of the better explanations, is that God made the two great lights, the greater light to govern the day, and the lesser light to govern the night. And I like this the last phrase there. It's kind of like it's tacked on there. Oh, by the way, He made the stars also, right? Yeah, I think that's pretty cool. So that's awesome. But I mentioned the movement of the moon. The moon is actually being kind of slingshotted just a little bit further out into orbit, a little further away. It's receding away from us. Right now it's perfect. It's great the way it is today. But think if you chart that back in time, even billions of years, it's too close to the Earth. In fact, and it moves away from the Earth about the amount your fingernails grow in a year. 4.4 centimeters or 2 to 3 inches or something like that. 2 inches, something like that. And the maximum age of the moon, if we chart it back, if it's been moving away from us at this rate, and we chart it back using the different differential equations and things, the maximum age is 1.3 billion years old is the moon, which most of those theories say the moon formed probably shortly after the Earth, which would be 4.5 billion years, which does not match, does it? How did the moon, how's it been moving over time? And there's just big problems with that, because even you see the dotted line around this the Earth in this picture. If the moon gets inside that, it would actually rip apart based on the Earth's gravity interacting with the moon. It would rip apart. We actually might get a nice little ring system there. That would be kind of cool. But it's good that we have the moon. It's perfect today because it's freshening the oceans, so oxygenating the oceans, so that the sea life is not stagnant and yucky, but they're fresh water oceans and different things. Some animal patterns and things are based on the moon. So many things. But notice, our moon is just one of many, many, many. In fact, I have it here, 146 moons in our solar system, and maybe some more that are being added here and there as they kind of fit the criteria to these other objects. So how did these moons all form? And there's some interesting things with a number of them that we don't really figure out. Of the surfaces of these moons, how did that surface form and crack and different things like that? Or So moons are really interesting, but they can't be explained, I don't think, without a designer creator, right? And then you've got dark matter and dark energy, which is interesting. And this is from NASA's first or main webpage regarding dark matter and dark energy. It says, what is dark energy? More is unknown than is known. Whoops, go back. What is dark matter? We are much more certain what dark matter is not than we are what it is. And again, like I said, I think I said it before, dark matter and dark energy are dark because we can't see them. We can't observe them. In fact, yeah, we can't observe them, we can't taste them, touch them, feel them, all these different things. We think it's out there, at least many scientists think that there is dark energy and dark matter out there, but there are only indirect evidences for them, and it could be many other things at play. In fact, and I say maybe it's out there, but I think for the most part, dark matter and dark energy are there to make the billions of years models make sense. I don't think we need dark energy and dark matter, but they might be out there. It's possible, but I don't know if it's what we really think it is, or what they claim that it might be. In fact, many people will add things to, well, maybe they help stars form, right? And that's sure, we can ask that question, but we can't really test that question, and we can't really know for sure. Evolutionists are putting dark matter, dark energy in their models and claiming that it can do all sorts of wonderful things because nobody can prove that it can't do all these wonderful things. So dark matter and dark energy might be out there, but I think they're just kind of made up to make the billions of years models fit. But I could be wrong on that. Water on the Earth is interesting. Water on the Earth, where did we get the water from? How did it all come about? That's a big question. Where did it come from? Because if you think about the supposed evolution of planet Earth, if all those rocks are supposedly building up, which again, we have problems with that, challenges with that, they're going to be hot, they heat up as you have these impacts, so you have this lava planet, crashing together, forming, and the water vapor is just lost to space. And there's big problems with keeping the water in the rock as it's forming into a planet. Maybe this is what our planet Earth should look like ultimately. I don't know. But it's interesting that here on Earth, scientists, they don't see evidence of a flood on Earth, right? But they say, some of them anyways, are saying there might have been a huge flood on Mars, is what they're saying, looking at the valleys and canyons that are cut on Mars. And they say the ruggedness of the waterways also suggests flooding played out quickly and violently on the order of weeks and months. Weeks or months. That's not quickly, that's not quickly, is it? That's pretty long and big event, right? And in fact, this says, Morgan, the researcher here on this group, he speculates there could be a layer of water stretching across much or even all of Mars at a stable depth of 5 to 10 miles. That's not a quick flood. That's not a regional, local flood, but that's a big flood, like huge, regional, worldwide possibly. They see evidence for that, and they'll claim evidence for that on Mars. But we see the evidence here on Earth, and we have the water still, right? We have, and it might have happened on Mars, maybe so. But here on Earth, we've got the evidence for it, and most people deny it. Most scientists deny that, and they say, "Oh, where did the water come from?" 70% of our land surface almost is water, right? Or the globe's surface is water, not the land surface. 2/3 of the Earth is water, which is that's where the water is. Today it's in the ocean basins, but the continents were different, right? So water, you can't explain water on the Earth very well with a naturalistic evolutionary perspective. I think it's better explained with a designer creator. In fact, we look at Earth's perfect placement. it's perfectly placed for life. Again, if it's too far away, it freezes. If it's too close, we burn up and die, right? Our atmosphere is just singed off. Here's what our life could be like, our sunrise could be like on the planet Gliese. This is just an artist's rendition of it, but this is a planet out there in space, Gliese. Thank God that we don't have that. That's pretty amazing. In fact, over the supposed billions of years of history for an evolutionist, a naturalist, the sun is actually growing inside. Well, the inside is kind of shrinking, but it allows the outside to grow, and it's getting brighter. This is called the young faint sun paradox. Back in the past, it was fainter. It's 40% brighter today than it was at its birth back then. 40% brighter today. So back millions of years ago, 3.8 to 2.5 million years ago, during the Archean eon, it was maybe 30 degrees Fahrenheit colder on average around the Earth. Which, why was it not a block of ice planet? Why was it not an ice planet if that's the case? And that's what these researchers are saying. We are trying to understand why there was liquid water on the surface of the Earth during this period of time, despite a much fainter sun. So I think it's been perfect throughout history, and not, well, I don't believe in the billions of years, so we don't have a problem with that since we only believe in the thousands of years. And then it's perfectly placed to even get solar eclipses and things on the Earth here, and we've continued our science and made discoveries because of solar eclipses, which is pretty cool. But all these different things are showing that, hey, Earth is perfectly placed and everything's just perfect for life. And I think that's God's provision and protection and design in all of this. Even the tilt of the Earth, so that we have the seasons of life, and again, the magnetic field, the distance from the Earth, and the tides are good. It's amazing when we compare the creation perspective, right, versus the naturalistic evolutionary perspective. Totally different conclusions we draw in these cases. Here's a naturalist, Carl Sagan. He was, 20, 30 years ago, he was the head person you look to for scientific information, especially with astronomy, with cosmology. He said, "Our planet is a lonely speck in the great enveloping cosmic dark. In our obscurity, in all this vastness, there is no hint that help will come from elsewhere to save us from ourselves." Wow. That's kind of sad, isn't it? That's kind of depressing, maybe. How about this? Stephen Hawking, one of the most respected today still. "We are such insignificant creatures on a minor planet of a very average star in the outer suburbs of one," and actually I have to stop there because our sun is, yes, there's a lot of stars like our sun, so it is, maybe an average star in that sense because there's a lot of them out there that are like ours, but most of those, pretty much all of those stars have huge solar flares happening every once in a while, all the time. They're not the most stable thing. That's just what stars do, is they have these huge solar flares and ejections off the surface of the sun. And we're very lucky that really our sun, at least from what we've been able to document, is very tiny. It has very tiny solar flares and things. So it's not a problem for us, really. But think if things have been trying to evolve for billions of years and a solar flare comes out and just wipes off our atmosphere, we need a new atmosphere. We got to start over, right? And that would be a problem for things trying to evolve over billions of years. But anyways, we are such insignificant creatures on a minor planet of a very average star in the outer suburbs of one of 100,000 million galaxies. So it is difficult to believe in a God that would care about us or even notice our existence. Wow. Totally different perspective than what we have, right? And in fact, here's Neil deGrasse Tyson, again today, one of the most, really one of the people that you would look to for information on astronomy, on all kinds of documentaries today. Most places in the universe will kill life instantly. Just look at the volume of the universe where you can't live. You will die instantly. That's not what I call the Garden of Eden. None of this, and he goes on this whole, and he calls it stupid design, or he calls it a tirade on stupid design. None of this is any sign that there is a benevolent anything out there. It's hardly an efficient plan for us in mind. I think he's totally got it backwards, because yeah, I mean, of course we weren't meant to live in outer space. You know, we'd die without oxygen, right? We'd die if we didn't have liquid water and the right temperature, you know, all these different things. And that's why the earth is designed so perfectly for life. That's an amazing God. He's just trying to pick at it and say, why would God have done that? God did it for a reason here on the earth. In fact, well, we'll get that in a little bit. How about this? Carl Sagan again. The cosmos is all that is, or ever was, or ever will be. That's it. But think about it too. These are scientists putting forward their science conclusions, models, theories, ideas, and but these are philosophy, really, right? These are philosophical statements based maybe on scientific evidence, but conclusions, these conclusions are really philosophical conclusions. This is his worldview that the cosmos is all it is, or ever was, or ever will be. And he might be trying to point these things to the evidence, but that's the way he views the world, ultimately. That's philosophy. When we look at the heavens, I think it's totally different. I think it's totally different. We see in God's Word that God has set eternity in our hearts. We have this awe and this wonder of the heavens. Wow, God, that's awesome. We have a desire for something bigger than ourselves, something greater than ourselves. That's God. That's the infinite. We're the finite. God's the infinite, right? We're just trying to bump into Him. He, God, is the maker of the Bear and Orion, the Pleiades, and the constellations of the south. He performs wonders that cannot be fathomed, miracles that cannot be counted. Wow. Miracles that cannot be counted. He's a big God. You alone are the Lord. You have made the heavens, the heaven of heavens, with all their host, the earth and all that is on it, the seas and all that is in them. You give life to all of them, and the heavenly host bows down before you. Wow. God's a big God. I hope you're seeing this. I hope you're getting a bigger view of God. That's what it's all about, right? The Lord by wisdom founded the earth. By understanding He established the heavens. He's a big God. So looking at this whole timeline, looking at this whole perspective, we see a lot of problems, right? I mean, we could probably cross the whole thing off, right? We could cross the whole thing off. Nothing's really matching there at all to the evidence that we're seeing. I think this is a much better perspective, worldview, that's more consistent with the evidence we have around us. In fact, I think it's amazing. Do you know how many times the Bible says the word earth in Genesis 1 alone? Genesis 1, the first chapter of the Bible. How many times does it say the word earth? 20 times. 20 times. God is talking about the earth. In the beginning, God created the heavens and the earth. The focus is on the earth. God's focus is here on the earth. You know, He made the sun and moon and stars to be lights for in the sky for signs and for seasons and for days and years on the earth, right? He created all of that for us. And you might be thinking, why did God do that? It seems like a waste of space. That's what a lot of people say. I can't imagine there not being anything else out there because that's just a waste of space. Shouldn't there be something else out there? Shouldn't there be something else out there? But I think it's God just saying, hey, check this out for size, and poof, for us on earth, to never forget how big God is. And as we continue to discover and do science, we learn more and more about who God is. You think about the focus being on earth in Genesis. The focus really then comes down to the last creation that he did, which was Adam and Eve, right? That was his prime, his favorite creation, I think. And you realize what it talks about in Genesis, about how God created Adam and Eve? When he went down like this. Took the dust, dirt of the ground. Breathed into Adam the breath of life. That's a special creation. That's intimate. That's a big God. We have a big God who cares for us. And then he did the surgery on Adam. Took the rib. As the skilled craftsman, skilled doctor in this case, the first doctor, the first surgery, and created Eve of the rib because he knew what Adam needed. He intended that relationship for Adam and Eve. He intended that relationship to live with them forever, to live with him forever in the garden. He's a big God. That's what he wanted. And in fact, I think if Adam and Eve had never sinned, they'd still be in the garden. If their kids had never sinned, and if nobody had ever sinned throughout the line of history, we'd be in the garden still today, living with God. He probably would have had to build a bigger garden, but we'd be living with God. That's God's intent. That's God's desire. So when Adam and Eve sinned, now we're under the curse of sin, because what? The wages of sin is death. We're under the sin curse of death. And so that's what God did. That's why God sent Jesus to die for us, right? So that we can live forever with him. Again, that can be restored. The wages of sin is death. And I'm glad that verse does not stop there. The wages of sin is death, but the gift of God is eternal life through Jesus Christ our Lord. In fact, you talk about God being there in the garden with Adam and Eve. When they sinned, it says he clothed them, he covered them when they were sent out of the garden. That's the first sacrifice. I think God did that for them, to clothe them of their nakedness. The first animal sacrifice there. You see sacrifice throughout the Bible. And God made the best and last sacrifice in dying himself as Jesus Christ for our sins. That's awesome. That we can live with God forever. In a better world, where there is no pain and suffering and death. A lot of people ask, why is there pain and suffering and death if God is such a good God? That's our fault, right? That's our fault. That's why there's pain and suffering and death. God's desire is to live forever with us in holiness, in righteousness, without pain and suffering and death. That's his plan. It makes sense. I think we use the words God loves you so much all the time. God loves you. God loves you. God loves you. Yes, he does. That's totally true. But I think sometimes it just goes over our head. I mean, we just think, oh yeah, God loves us, of course. Think about this. God cares for you. God thinks about you. He's thinking about you right now. Because he's infinite. He's all powerful. He totally could be thinking about you all the time, every day, everywhere. And everybody else. But he's thinking about you and me. He's a big God. Wow. I haven't even got to these verses yet. He numbers, this is God, He numbers the stars and calls them all by name. 1, 2, 3, 4, 5, 6, 7. Joe, Robert, Sue, Dave, Jill. Right? God numbers the stars and calls them all by name. That's huge. Let's put this in perspective for you too. You look at the universe, all of this stuff. You look at the Milky Way galaxy. This is what we think the Milky Way galaxy looks like, a nice spiral galaxy. We think there could be as many as 300 billion stars in the Milky Way galaxy. Some galaxies may be a lot larger than that. 300 billion stars. We're just one dot kind of in the blank spaces, maybe in between the stars, where it's not too hot and we're not frying up. 300 billion stars in the Milky Way galaxy. They've estimated, given all that, there's maybe that many stars in the whole universe. That's a lot of stars. What is that? Hundreds, thousands, millions, billions, trillions, quadrillions, quintillions, 70 sextillion stars in the whole universe. It's a rough estimate. I wouldn't be surprised if there's more. Right? 1, 2, 3, 4, 5, 6, 7. We'd never get to that number. Never. Bob, Joe, Susie, Phil. Wow. God's a big God. Let's go back to that verse. That was actually the bottom verse here. That He numbers the stars, He calls them all by name. Look at the verse right before that. He heals the brokenhearted and binds up all their wounds. He's a big God. He can do whatever He wants. He can count and number the stars and name them all. But what does He care about? He heals the brokenhearted and binds up all their wounds. Who are the brokenhearted? We are, aren't we? God's a big God. Wow. That's amazing. Your eyes have seen my unformed substance, and in your book were all written the days that were ordained for me, when as yet there was not one of them. How precious also are your thoughts to me, O God. How vast is the sum of them. And I think God's thinking about each one of us. God thinks about you. Which means God cares for you. God loves you. He's a big God. So all this being said, looking at the heavens, beautiful. We're in awe of it, right? I think truly the heavens declare the glory of God, and the firmament sheweth His handiwork. I hope your God has become bigger tonight. I hope you realize you can trust God from the first verse to the last verse. Thank you. You guys want more? You want more? Well, how about this? Many of you, since we're talking about astronomy, we're talking about creation and the creation perspective. How do we explain distant starlight? Right? That's a big question today. One of the biggest challenges, I think, that creationists face is, how do you explain distant starlight? If the Bible says there's only 6,000 years of Earth history, and out there in outer space, light only has 6,000 years to travel from very distant objects, that it would take much longer, it'd take billions of years to get to us, based on even our observations of how far these objects we think they are from us. How does light travel all the way here if there's only 6,000 years of Earth history and not billions? So light has traveled from very distant objects. And so many people say, well, then the universe must be billions of years old. Must be. No, I don't think so. I think there's some options. And so many people will disregard the Bible, saying this can't fit. This refutes the Bible because you have ages longer than 6,000 years for Earth history. I think there's some answers to this. I'm not going to give you all of them that I've come across, but maybe some of more of my favorites here. And so number 4 here, that being the dasha solution, this is maybe a good possibility here. That just like God quickly sprouted, which is the Hebrew word dasha, sprouted the plants on day 3, God may have stretched the light over the heavens on day 4. Just like that. Because it does talk about God creating the fruit trees and things with seed and fruit in them. And so he created them mature. He created Adam and Eve mature. In fact, which came first, the chicken or the egg? God created the chicken first, right? As mature. In fact, actually, he created the chicken with seed in it, probably, with the eggs in it. So actually, God probably created the chicken and the egg at the same time. The chicken having all the eggs it needs, or many of the eggs inside its body. But there you see the vegetation sprouting up on day 3, right? Dasha, sprouting. And it could be the same thing with the light, where it is stretched out on day 4 or during the creation period. In fact, we have many verses in the Bible that talk about God stretching out the heavens, right? God stretched out the heavens like a curtain and spreads them out like a tent to dwell in. He stretches out the heavens. Many places in the Bible it talks about God stretching out the heavens. So maybe that could be true. I don't know. Is that do we take that as a scientific term, or is this a figurative wording? I'm not exactly sure, but we've got that in God's Word. How about this? Time is relative. Different places experience more or less time based on where they're at and what's going on throughout the universe. They experience different amounts of time. An example being a clock at sea level ticks slower than a clock on a mountain, because the one that's at sea level, it's closer to the center of the Earth. It's closer to gravity, and so it's actually, and it's not moving as fast as something would on the top of a mountain. So you have both gravity and speed of travel affecting how much time is ticking, which is interesting. Take this example here. You have 2 twins on this main ship here, and there's a planet down there, and you say, oh, why don't you go down and observe and take some notes and take some samples of rock and different things down there, and do some experiments down there. So he takes his shuttle, his little transport pod, and goes down towards the planet, right? Oh, notice what happened to his other brother. Here, let's back that up. They're twins. They look the same. What's happening to his other brother? He's aging. Why? Have you seen the movie Interstellar? I love that movie. It's because I'm nerdy. I'm like that. But it's based on this idea that they go down to this planet. It's closer to a black hole. And so they're actually experiencing less time because they're closer to a gravity source, a heavy gravity source. And so over time he's there picking up rocks. And notice what's happening to his brother that's further from the black hole. More time is happening out here than the brother doing the experiments. In fact, he does some experiments right there on the planet with his microscope. And look what happens to his, he sees doing his experiments. Look what happens to his brother. Just age. A lot. That's a challenge, huh? Right? So time is relative. Different parts of the universe have experienced more or less time, different amounts of time. Near the black hole would be less time, near a gravity source. Away from that would be experiencing more time. So maybe we're talking about one day being just one day on the Earth and not elsewhere in the universe. Maybe so. The cosmic local time. And in fact, here's Russell Humphrey's idea. achronicity or timelessness cosmology, where if everything's packed together at the beginning, because God's going to stretch it out, it's packed together. In fact, he says, if we talk about the waters being separated and you have the expanse above, maybe that's the expanse above, or he actually points to a verse, Psalm 148:4. Is this figurative? Is this real? I don't know. Praise him, you heavens of heavens, and you waters that be above the heavens. Are we talking about heavens like the atmosphere, or are we talking about heavens like space as it is? And that the boundary of space here is this water that's encapsulating everything. And if that's the case, Russell Humphreys says maybe there's this zone inside that's timeless. There's no time happening inside, in the middle of this big shell of water all the way on the outside. So you have no time. You have some time in the middle, though. You'd have some time in the middle. And think about it like a trampoline, where you put a ring in the middle of the trampoline, you push down that ring. It's going to be flat inside that ring, curved up to the edges on the outside of that ring. But if you were to take the netting outside the ring and spread that, the ring's going to move up. Here's another perspective of that. That's that ring impression inside the trampoline. If you stretch or pull the outside, that is going to come up, right? And it comes up beyond the event horizon, or the timelessness horizon. That's that white circle around the gray. And so as you stretch the outside, watch, then the timelessness, the place where there is no time, shrinks down to nothing and becomes not. Everything is experiencing time. Everything is experiencing time. That's an interesting one. It's interesting. It explains how we've got things maturing or aging out there in the universe. If this is the case, if they've had time to age. Kind of looks like that, a shell of water around the outside of the universe. Everything else on the inside. And it's expanding, is the idea. Okay? Kind of funny, kind of interesting. How about this? And I kind of like this one. It's kind of unique. It's kind of interesting. The anisotropic synchrony convention solution. That I believe Dr. Jason Lisle came up with, the creationist came up with this idea, formulated this, as far, or at least he's a proponent, big proponent for it, I believe. And it's this idea that the speed of light is different, could be different in different directions. Because every time we measure the speed of light, in fact I might have that here, speed of light calculations are always based on the average speed from there and back. It's always an average there and back. And so, it takes time. We send a beam of light to a mirror down there, it hits the mirror, comes back, right? But what if and here I have a little, and we've done that, we left some mirrors on the moon, so now when we look up at the moon, and we focus in on that, where that mirror should be, we can send that beam of light, hits the mirror, comes back, with all the calculations all in order and everything, we can figure out how far away the moon is, and then we're seeing the moon is moving away from us, right? So in this case, we send our beam of light out, it travels out there, and it comes back. Normally, that's what we expect. But we don't know if that's the case. We don't know for sure. We assume that to be true. It could be that you send a beam of light out to the moon, and it goes extra slow here. Ready? It goes twice as slow, and immediately it's back. I don't know if you caught that. It went twice as slow. It took the whole time to get one way, and then it's immediately back. Infinitely. Like, all of a sudden there, with infinite speed. Does it happen? Maybe. We don't know for sure. We assume it doesn't. We assume it's average speed both ways. So maybe when God created the heavens and the earth and all this stuff, maybe all of a sudden, boom, the light was just there. And God could have just done that. And in fact, that's one of the options here really, when it comes down to that, is that God could have worked outside of the natural laws, because He's God. He's all-powerful, right? In fact, here's a quote here. If you think about it, it is irrational to argue that a supernatural act cannot be true on the basis that it cannot be explained by natural processes observed today. So it's irrational. If the supernatural is a possibility, then it's a reasonable, rational explanation. It's okay. It's an okay explanation. It's rational. It's irrational to say that that cannot be true, even though maybe a supernatural force is acting. And we can't prove that for sure, whether yes or no. I think there's evidence for it, but obviously there's faith, right? Like, as we've talked about and can talk about more extensively. So ultimately, I always bring this up with people. In fact, sometimes I almost forget to bring it up, but this is the key aspect of all of this. This distant starlight problem is normally hurled at us as a problem for the young Earth creationists. But the same is actually, and so we can give them some answers, and we gave them some answers, right? But the same is actually a problem for the naturalists believing in billions of years as well. It's called the horizon problem. And so this is a huge aspect. Well, they can't say our model is wrong because they have the same problem in this case. They have more problems than we do, right? But it's called the horizon problem, where all over the universe, the cosmic microwave background radiation, which is supposedly the leftovers of the Big Bang, it's an even temperature everywhere. They're showing that the universe is an even temperature all over the place, basically. It's very smooth, or it's very even. Looks kind of something like that is what they say. This is not the actual picture, but it looks something similar to this. And very even throughout, which is a problem, though. It's a challenge, because if you have a hot spot here and a cold spot down here, and if the universe is stretching, and I think I agree with that. I believe in that too, that the universe is spreading from, they would say the Big Bang. I would say it's just God stretching the heavens, right? They still can't have light traveling far enough to cool off everything to the same exact temperature. It's kind of like a hot cup of coffee and a cold ice cube, right? And if you stretch them out, they'll never touch. They can't, yeah, that might still lose some of its hotness, and this one might warm up a little bit, but they won't be able to be such an even temperature, which they really are. And so then the Big Bang, person believing in the Big Bang has to come up with the theory of inflation. Is basically one of the reasons for the theory of inflation is that then you have different parts of space stretching in different ways, inflating in different ways, and then you can have these places contact each other. But there's no real evidence for the inflation theory other than it has to be there for the billions of years models to make sense. It has to be there, so this light travel time problem is not a problem for them. But it is still for them as well. And so when we look at that, I don't think that's a big problem. I think, God is God. He can do whatever He wants, right? He's big enough. He's powerful enough. And I think if that's the hardest problem we have to answer, I think that's pretty good, right? I think ultimately you can, like I've said before here, you can trust God from the first verse to the last verse. So I hope that helps. Does that help? All right. Thank you. I appreciate your attention. God bless.